Hello guys, welcome to my YouTube channel. In this video, I'm going to continue to talk more about insertion sort algorithm of chapter 2, section 1 of the book and explain about initialization, maintenance, and termination of an algorithm. And any algorithm should satisfy these terminologies and make you ready to solve exercises of this section together in the next videos. Suppose that we are given an array for example A, which contains elements 36, 2, 10, and 5, and it's asked us to order them increasingly from left to right. If you take a look at the algorithm, it has a main for loop. It goes from j equal 2 to the length of A. Here, the length of A is 5. So the j goes from 2 to the 5. So let's make this j shows the second element. Now, we also write I equal j minus 1. So I is 2 minus 1, it's 1, shows the first element. Now we check that if we can enter to the while loop or not. I is positive, I is 1, so it's positive. And AI is more than the key. Key is here, key is 6, is the second element, which we want to insert to the left-hand side. We always suppose that the left-hand side of the key is sorted already. So we want to enter this. So the key AI is not more than the key. 3 is not more than 6. So we won't enter to the while loop. And I plus 1, which is I plus 1 is 2. A2 is key. So we went down in the for loop. We should increment j1 more. J was 2. Now it should be 3. So let's increment j is 3, which is showing the third element, which is 2. So this is key. Now the key is 2. I is j minus 1. So I should be in here. I shows the second element. It's better to keep the key in here. So AI plus 1 should be AI. So here the third element should be this one. We decrement I by 1, so it shows in here. Now we check if we can exit the while loop or not. I is positive, yes, and AI, which is 3, is more than the key. So we should enter again to the while loop. Now AI plus 1, which is the second position, should be AI. So we just need to bring 3 in here and decrement I by 1. So I now should be 0. AI 0 is not positive, so we can exit the while loop. AI plus 1, I0, AI plus 1, which is A1, should be the key element. So the key element comes in here. Now we went down the for loop one time more. So it's time to increment j by 1. For loop, every step is 1. So we increment j. And j now is showing the fourth position. So we copy the key element, which is 10, in here. Let me delete this. So this is the key element. Now I should be j minus 1. J is 4. I should show the third element. It's time to check if it's the condition to enter to the while loop. I is positive. Yeah, I is 3. And AI, which is 6, is more than key. No, it's not. So we won't enter to the while loop. Now AI plus 1, I3, AI plus 1 is A4, should be key. So in here, we didn't do anything. So again, we should continue the for loop. Now we increment j one more. So j is 5, is showing the fifth element, which is 5. We copy this 5 in a key and we make I equal j minus 1. J is 5, so it is 4. Now we check that if we can enter to the while loop or not. I is positive, yeah, I is 4. And AI, which is 10, it's more than the key. key is 5, it's more than key, so we should enter to the while loop. AI plus 1 should be AI, so we will copy in here and we decrement I by 1. So I goes to the left hand side, which shows the third element. Now again we check the condition for the while loop. I is positive, yeah, I is 3, and AI, which is 6, is more than the key element. Yeah, it is more. So we should enter to the while loop. AI plus 1, which is A4, should be AI, which is 6. So we just bring it in here to the fourth position. And now we decrement I by 1. So I goes to here. Now again, we check the while loop. I is positive, yes. And AI, which is 3, is more than key, no. So we won't enter to the while loop. And AI plus 1, AI is 2, so A3 should be key. So key goes to the third position. And now J is 5 and the for loop will not run again. So the algorithm is finished in here and the elements are sorted. Notice that we always needed to copy the J's element, AJ, into the key. And the other things, we just shifting the one card to the right hand side. So because of this, we can say that the algorithm is in place. It means that we don't need a memory which is in order of the length of the array. The length of the array is 5, and we just need one element to copy the J's element. We don't need another thing, so the algorithm is in place algorithm. In every algorithm, we should check that initialization, maintenance, and termination are satisfied. So we can say that the algorithm can work properly. We begin by initialization of this algorithm. It means that at the beginning, when we made j equal to the elements that we entered, it means that the left-hand side, A1, is already sorted. So the algorithm is okay in initialization. If you know the inductive algorithm in the mathematics, it's called base case, and we always check that if the base case is satisfied or not. After that, it's maintenance. It means that after each for loop, and whenever we begin the other iteration of the loop, we should check that if the algorithm works or not. When we increment j1 more, the left-hand side in this algorithm, it's sorted, so the maintenance also is satisfied. It's like the inductive step. If we want to prove by inductive that equality holds, we check that if it can go from a step n to a step n plus 1. In here, we always check that if when we are going from step j to j plus 1, the array on the left-hand side is sorted or not. Another thing that we don't have in inductive, it is termination, and we should check if the algorithm will end or not. Sometimes some algorithms, when you are writing, it may fall into an infinite loop, so the algorithm won't end, and you should, I don't know, stop by hand. In the insertion sorting algorithm, the for loop starts by j, and it will increment 1, and whenever the j comes to the end, to the n, so the algorithm will stop, so we have termination. Always for the for loops, the termination is satisfied. The problem is by while loop. Sometimes the while loops can enter to the infinite loop, and you should check that you have an increment. In here, I is always positive and we decrement it. So whenever it becomes 0, so this condition won't work. So for example, when j is 4 and I 3, so we increment I 3 times, and whenever it becomes 0, we will not enter to this while loop. So this while loop always will terminate. So the termination also will work for also while loop and for loop. Another terminology of this chapter is object. Here, for example, A is an object and its length is its attribute. A is our object and A.length is one of its attributes.